Hello dear students, welcome to my physics channel Physics R&T. I am Ramesh Narayan Tripathi. Today we are going to solve a good numerical problem related to Carnot heat engine and refrigerator. The question is, in the given figure Carnot engine drives a Carnot refrigerator. Find Q2, Q3 and Q4. Now solution. Here this is the Carnot engine in which the working substance draws heat Q1 is equal to 1000 joule from source at higher temperature 600 Kelvin and rejects heat Q2 to the sink at lower temperature 300 Kelvin. And with the remaining heat it does work W. Now with this external work done, the working substance in Carnot refrigerator, heat Q4 is drawn from cold body and along with external work done W, this heat Q4 is sent to the hot body. Now for Carnot engine, efficiency eta is equal to 1 minus T2 upon T1, which is equal to 1 minus Q2 upon Q1. This gives T2 upon T1 is equal to Q2 upon Q1. Hence we get Q2 is equal to Q1 T2 upon T1. So Q2 will be equal to 1000 into T2 300 upon T1 600. So it gives 500 joule. So Q2 will be 500 joule. Therefore, W will be equal to Q1 minus Q2, which is 1000 minus 500 is equal to 500 joule. So the work done by Carnot engine will be 500 joule. Now for the refrigerator, coefficient of performance is denoted by beta and is equal to the ratio of heat drawn from the cold body to the external work done, that is Q4 upon external work done. This is heat drawn from cold body upon external work done. And this is also equal to T2 upon T1 minus T2. Therefore, Q4 will be equal to W into T2 upon T1 minus T2. W is 500 joules, T2 is 400, T1 is 500 and T2 is 400 for the refrigerator. So it gives 500 into 400 upon 100, that is 2000 joules. Now Q3 will be equal to W plus Q4, that is 500 plus 2000, that is 2500 joules. Thus we have Q2 is equal to 500 joule, Q4 is equal to 2000 joule, and Q3 is equal to 2500 joules.